Good afternoon and welcome to today's webcast presented by Machine Design, New Equipment Digest, and EHS Today. Our topic today is Challenges in Machine Safeguarding, sponsored by Schmersal. I'm Bob Vavro with Endeavor's Design Engineering Group. Let's start by talking about how you can participate in today's presentation. If you have any technical difficulties during our webcast, simply hit F5 to refresh your webcast console. If you need assistance solving common issues, please click on the yellow help icon below the slides. We also welcome your questions during today's webcast, and we'll answer as many as we can during the Q&A session that will follow the main presentation, so feel free to send in your questions at any time. To do so, simply type the question into the question window on the side of your screen and hit the submit button. Also, today's webcast is being recorded and will be available on all of the websites within the next week. You'll be notified by email when the archive is available. So let's meet this afternoon's speaker. Mike DeRosier is a TÜV certified functional safety engineer for machinery. He has more than 20 years of experience, including controls engineering to design, build, and integrate full machine control systems. You can learn more about Mike by clicking on the blue speaker bio widget on your console toolbar. So Mike, we have a great crowd to listen this afternoon. We're looking forward to today's presentation. Thanks for joining us.
Thank you very much, Bob. Appreciate it. Hello, everybody. And first and foremost, we know these are challenging times, a lot of stay-at-home orders, not only across the U.S., but around the world. And first and foremost, we hope everybody's staying safe and healthy. And we know that there's an impact, and time is always valuable, and including times like this. But definitely here to help and try to answer any questions that we can. So we appreciate the time that you're taking to attend today's webinars and challenges in machine guarding. And we hope you're able to pick up quite a bit from it as a result. I'm going to get right into it and cover that topic. And as we do with other webinars, we try to take on topics to try to help answer some of the tougher questions out there. And I think challenges in machine guarding is no different than that. And a lot of times when you talk to people and think about it, when you're dealing with your day-to-day business itself, this image to me is a perfect image. You know, having that world on your shoulders, and you know, with what we're talking about today, machine safety. You know, having machines out on a production floor or being built by a machine builder, and not having proper safety, and maybe it's existing machines and not having that proper safety on there. Sometimes it seems like such a big subject to tackle and not knowing where to start, where to begin, where to show any kind of progress to making machine safeguarding and providing a safer machine and a safer workplace for people to work in, with still maintaining productivity, because there's a balance there. So having that world on your shoulder, how do you really move that and get it off center to where you need it? And that's what we want to try to cover today. So one of the first things we want to talk about is the reasons. Why do we have some of the challenges in machine guarding? And whether it's existing or newer pieces of equipment, if you look at these bullet points here, and over the next several slides, I'm going to talk about each one of those bullet points, but they're all reasons of why we see challenges in machine guarding. Whether we have that justification or not, whether we have resources. Education is probably one of the biggest factors when it comes to machine safety. And again, we'll talk about each one of these, but you can see on that list there that there's some definitely good reasons of why you hear or even run into why we can't effectively protect people with machine guarding and still be able to run. So one of the first ones I want to talk about is the challenges in machine guarding with the justification of not knowing. What you're seeing up on the screen right now is just 4 different quotes that I picked out. And in all honesty, I'm not making these quotes up. I have not heard these once, but I've heard each one of these quotes multiple times from people over the years. And I wanted to talk about each one of these. And to really make that statement of that ignorance is bliss. And I'm sure many of you have heard that just in life, ignorance is bliss. So if I don't know about it, then I don't need to do anything about it, because not knowing, there's nothing to do. I can plead ignorance. I didn't know any better. What you're going to find with all of these is these are not acceptable. When you look at it, just because you don't know anything, ultimately we have to protect people. How do we go about doing it? The end user did not specify machine safety, and it is their responsibility. When you look at a lot of areas, it is on the user, the end user responsibility to ensure a safe workplace. That doesn't alleviate a integrator or an OEM or a machine builder from safety responsibilities. And just because an end user didn't specify it, it may be because they don't know. They don't know what to ask for. It's going to come back, and we're going to hit this a couple times. It comes back to education. When we say education, we're talking specific to machine safeguarding itself. The opposite side, it came from the machine builder that way. Well, the fact that it came from the machine builder that way, there's always the assumption that a machine builder knows every standard out there and knows exactly what to apply because they're the quote-unquote machine builder. There are machine builders that do know that because they run into it. They've been driven by their customers to do it. But it's a collaboration. It's the end users working with the machine builders together to get to a safe machine. And just because an end user may be quoting out a custom machine and quoting against 3 other manufacturers doesn't mean that you should forget the machine safety in that scope of supply, so you're comparing apples to apples, for example. I didn't know we needed to do that. Well, again, it comes back down to the education. But ultimately what you find with all these, there are things that people say and come up with reasons why they haven't done machine guarding. But the bottom line is what you see down there, we need to protect people from serious harm and fatality. That's easy to say. It's certainly not easy to do. So we can't justify not doing something on machine guarding just because we didn't know. We learn, we figure out what we can do, and find that balance between machine guarding and productivity. Next one in that bullet points was the machine wasn't designed for safety. And this is real. This is what's out there. Whether a machine is 40 years old, 60 years old, there's machines out there that are still performing their job function as they did when they were originally designed. But way back when, the machine was designed purely for productivity and not for protection of people. It was done to put out a product or a process. As a result, and machine safety never came into the consideration. Because it was designed for function, it's not the easiest thing to add machine guarding to that existing machine. Like you see in that picture there, that's an old machine, looks like a conveyor type of machine, may have some processing on the front end of that. But if you see those big drive wheels, that's an older machine that you see that would have one main motor that went with those leather belts, for example, to drive that. There's no controls. There's no e-stops. How do you stop it? You let go of the belt so it doesn't drive the machine anymore. Just because it may still function doesn't make it safe for people to work around. So how do you actually develop guarding to work around that? It may be adding controls. It may be adding a standalone motor with safety controls. From there, you might be able to add guarding around that. You may be able to put light curtains. But what does it really stem from? Goes back to that educational piece, that knowledge. Knowledge is power. But the fact that because this is the way it's always been done, it becomes an acceptable practice doesn't come in as justification or reasons to not put guarding on a machine. If this machine can seriously hurt or kill somebody, we have to try to find a way to guard that. And again, easy to say, not easy to do. So we're going to go through those steps of what to do and how to do that after we go over some of the reasons that you see or hear. Another big one is the lack of resources. Not having the personnel to be able to do that, not having your engineering, whether it be internal or external resources to be able to do this. Somebody has to look at it. They have to come up with a concept. You have to look at risk assessment. What do you need to do? How do you need to go about doing it? How do you design it? Who's designing it? Are you fabricating it? Are you using a fabrication shop, a sheet metal shop for a guard? Somebody does aluminum extrusion, wire, steel mesh fencing. Who's actually doing that? Who's responsible for it? Is it your own internal maintenance people? Well, maintenance has a heavy job load as it is. They may not have the time or the resources within that department to do it. Do they have the knowledge in machine guarding to get you exactly what you need? Some facilities have that capability. Others do not. So where do you find those resources? Well, if you don't have them internally, if you can't set that priority, you need to look at external resources to help you, whether it's external engineering companies, whether it's external integrators that work with machine safety to help you along with that process. The next one, and I'm going to spend a little time on this, education, the lack of education. And I want to make sure that this is clear. When we say lack of education, it's not due to lack of any kind of college education, degrees, anything like that. It's the education and the knowledge that's specific to machine guarding, machine safety. Whenever we do training classes, one of the questions that we like to ask of the class is, by a show of hands, how many people here have some sort of college education, college degree, whether it be a 2-year, 4-year, 5-year degree, in whether it's environmental health and safety, whether it's mechanical engineering, electrical, controls. I don't care what the discipline is. And you'll see anywhere from half to most of the room raise their hands up. My next question comes down to, okay, in all your years of college education, how much time did you spend specifically on machine safety in your particular discipline? Now you see all the hands go down and many people putting up their hands with the symbol of a 0, that they've had no time on machine safety. So a lot of the machine safety comes from on the job. I've ran into some phenomenal engineers out there in the field, both from a manufacturing standpoint, an end user standpoint, a machine builder standpoint, that these engineers can spin circles around a lot of people. They're so strong and so knowledgeable in what they do. And the typical engineer will do what they feel or what they know is best practice. Well, if nobody's ever given them that education side specific to machine safety, how do they do that in their process? They've built some phenomenal designs and fabricated them and did some wonderful things that makes life easy, develops this to do this, and do a lot of different things with it, but then the machine safety is lacking. But once they get that machine safeguarding knowledge, that gets incorporated with the designs, and it just takes them to that next level. And you can build machine safety in with the design on it. So a lot of that does happen on the job, but getting that machine safety aspect is important. How do you effectively guard any kind of machine or piece of equipment or process out there without having that education? Meaning, where do you start? What do you go with? What do you design to? Is there specific standards that relate to that particular piece of equipment? Is there a baseline standards to at least get proper practices and quality of guarding aspects and being able to work with the machine? So education is probably one of the biggest parts in embarking on any machine safeguarding type of project. Next one is understanding of standards. And anybody that's ever went through any of the standards, whether it be OSHA standards, ANSI standards, ISO standards, NFPA standards. There's a lot of standards out there. There is a whole laundry list from different organizations, and I'm just talking specific to machine safety functionality. You have ANSI standards for machine tools with the B11 standard. We have ANSI standards with the RIA with robots and robot cells, mobile robotics. We have ISO standards for the same thing. We have ISO standards that talk specifically about e-stops and minimum safety distances or approach speeds and safeguarding and safety distances. There's a lot out there. So one of the first steps in breaking down that challenge is what standards are out there. Understand what standards are there and what really applies to the specific machine or piece of equipment that you have in your facilities or what you're building as a result. But then part of that comes down to, because there are consensus standards, they're written in ways to try to make it as clear as possible, but sometimes there may be in some standards some left up to interpretation. As a company, what's the interpretation? What is the company definitions? And then ultimately being able to take that as standard and taking the words out of that standard and applying it in real life. How are you going to go about doing that? It all stems back to breaking it down, getting that understanding of the standards, and using those resources to put that into play. Missing a process for machine guarding is the next bullet point. Well, part of it is, and if you think about any cogs of a wheel or a gearing system, you miss one cog, it doesn't work. It doesn't move. Getting off that machine guarding into getting it to functional and becoming a process, you need to determine first, how are you going to get it accomplished? What's your procedures for doing that? What's your risk assessment process? Looking at designs and who's designing it. Is it internal engineering, external resources? What is the scope of supply? Meaning, what are your expectations of that machine? If you're purchasing a brand new machine, is your scope of work or your scope of supply detailed enough to say, okay, this is how many widgets has to be produced a minute, and this is how many has to be produced a minute, but it has to be done safely with effective guarding, and detailing that out as part of the scope of supply. Scope of supply also pertains to using, whether it be internal or external resources, to update existing pieces of equipment, adding guarding. What are the expectations? You need to know what you're asking for to make sure you get exactly what's needed to effectively protect people, but still be able to work with the machine. And I mentioned just a minute ago, the risk assessment process. Do you have a risk assessment process? How do you know you've tackled as many of the risks that are possible on the machine? You may not capture everything, but if you don't do a risk assessment, how do you know that you've captured most of what's out there? Did you come up with a solution? Where's the acceptable level of risk that can be followed up with process and procedures? So going through and understanding the different processes that you need to move forward with machine safeguarding is one of those challenges, because missing a piece of that, you never get to that point where you would have effective guarding, because something can get missed because of something missed in the process. The next one, following up what we were just leading with that last slide, is the risk assessment. There's so many times where you may ask, well, where's the risk assessment? Show me what your risk assessment says. And then you get, well, we never did a risk assessment. Okay, how do you know what you need guarding for if you don't know what the risks are associated? What are the hazards on the machine? What's the quantification process, and what numbers? What do the numbers really mean? And we'll talk a little bit more about risk assessment in just a few slides later on in the presentation. But knowing or determining where is it acceptable. There's risk in everything we do in life, not just working around machines. You can't guard from everything, but where is it acceptable at that point in time? Now when we roll back into machine guarding, it's the same thing. There are certain risks that you see that the odds of it happening and the severity of harm are so low that it's process and procedures and training at that point in time. There's other ones that, man, this can take off your finger and they're in there all of the time. We have to effectively guard this. How do we go about doing it? Where's the priority? And that's where that quantification method is going to get you to. But knowing and understanding the hazards and getting a risk analysis and then ultimately a risk assessment to get that solution in place is what's going to be important in the process as well, because you need to understand where you're at and where you need to get to really determine what guarding measures need to be put into place on the machine. Next one is culture. And to me, this is probably one of the most difficult things to change in anything you do in any organization. Changing culture, changing human nature to think. If you're in a facility where people don't believe in the guarding, that's a challenge because they'll find ways to make sure the guarding doesn't work. You have to change that culture. Just because it's always been done that way, that's just the nature of that machine. We've always worked with it this specific way. That doesn't make it acceptable, but it makes it a challenge on overcoming that culture. Hey, nobody's been ever hurt on this particular machine. We don't need guarding. Well, just because nobody has never been hurt doesn't mean nobody will ever get hurt on that machine. It makes a big difference. You can have areas where you get people refusing to change. Well, what that means is you need to have management involved with this, and it has to come from top down. Management has to believe in protecting people and doing that way, enforcing those changes and causing repercussion. Meaning whether it's immediate removal from the area, maybe your company policy is a 3-strike rule. Hey, first you get warned, next you get sent home for the day. The third time it occurs, you're dismissed from this company as an employee. And I hate to be very harsh and crude on something like that, but when you got people that are willfully bypassing safety devices or they're acting in unsafe manners just because they don't think something bad's going to happen to them, as humans, we tend to take on a lot more risk when it's ourselves versus somebody else. And part of thinking about and how to change that culture is if you can walk up to a machine and ask one simple question. It's fine if you work on it. Would you be completely happy and comfortable letting somebody you care about work on that piece of equipment? Your wife, your husband, your child, your mother, father, aunt, uncle, people that you love. Would you be okay this afternoon putting them on that machine and teach them how to use it given that current condition? And if you can answer no to that, why are you letting anybody else work on that machine in an unsafe condition? And that's a big, big question. And it's not always the easiest thing to either answer or face, but looking at those challenges. But it comes back to understanding where your current culture is, where you need to get to, but it takes time. You're not changing culture overnight. It takes time to do that, and you slowly show that progress as a result. If you put effective machine guarding on there, that you take in consideration on how people need to use that equipment, but now they can use it safely with minimizing the impact on productivity, you can make machine safety work. If you put a box around the machine and see productivity drop down to 10% of what it was, great, you protected people, but you're not making money as a company either. That doesn't work. But saying something must be unguarded because it's going to impact production that much is not acceptable either. What levels of guarding can we put into place? So with overcoming all of those challenges, there's a lot of different ways to look at it, and what we laid out here is looking at, I broke it down into 5 steps as part of your process. First one is coming up with a strategic plan. That's where you're starting. Just going gung-ho, love the energy to do it and wanting to protect people, but it's not going to be successful if you don't start with your strategic plan, meaning what corporate policies are in place, what standards, what government regulations. They're going to vary. For example, we may have, just in the U.S., you have OSHA as our governing body. There's certain standards. Well, there's national OSHA or federal OSHA, but then we have states that have their own OSHA guidelines. There is a minimum to meet federal, but they may take it a little bit above as well on certain areas. We have in Canada, specifically in Ontario, the Ministry of Labor. We worry about different government agencies in other countries and what the local municipality and government regulations are, understanding what they are needed in those specific regions. It's one thing to take it above, you can never take it lower than what local regions are. So knowing what that strategic plan is, then also building on that is training. What training needs to be done? Who needs to be trained? And we're going to break through each one of these over the next 5 slides as well. The risk assessment process, I'll go into more details on that one. We talked a little bit about that previously. But then we got the implementation plan and the integration. The implementation plan is determining how long is it going to take? Who's doing the design? What is the design? Is there a review of that design? How do you measure progress and moving forward? But then when it comes time to install that machine, how long do you need that machine out of service to do it? Is it 1 day? Is it a week? What do you need to do to implement safety and prove it out? How do you validate it? How do you make sure it's doing what it needs to do? But you see here, even though we kind of started at strategic planning and went down to the bottom of the list, we got an arrow going back up to the top again. It's not a start and stop process. We change, we evolve, we learn things over the years. New technologies come out because there might have been something that you were able to do partial guarding, but the technology wasn't there to do full guarding. Maybe there's a new type of device out there that improves your guarding without sacrificing productivity, and it makes it more user-friendly. So going back up and always evaluating your policies and procedures, you're always bringing new equipment in there. There's always newer technologies that are coming out. Are we using the latest and greatest to make us more productive and maintain or increase our safety levels? Do we need more training as a result? We got new engineers that are hired out of college. We have transitioned from one company to another. We have people that have retired. You got change in the workforce. That education, that training needs to be continuous. Changes happen to current machines. Have a risk assessment been done again to follow those changes? Have standards changed that says, hey, we need to look at this. Now that this technology is out there, we should be doing this on this particular type of machine. Does that need to be upgraded on the existing piece of equipment? So that's why this is a continual process. The next thing we're going to talk about now is breaking down each one of those points. So the strategic planning. Understanding, as we mentioned, the local government regulations. But that's not the only thing. A lot of government regulations may also refer back to industry consensus standards. Why? There's going to be a lot more details in the industry consensus standards because, as the name talks about, industry consensus, that specific industry. So you have people from suppliers, you have people from the end users, you have the equipment manufacturers, representatives that have come together in committees to help generate and write this standard that makes it practical from everybody's point of view and perspective to make it easy. It's not weighted that, hey, this is all suppliers just trying to push their product, or this is all machine builders on this trying to avoid having to put any guarding on a machine. No, it's a consensus. that these people come together to talk out and figure out what's the best way to approach that specific industry or that specific machine. Maybe your company has corporate machine guarding standards. Are they up to date? Are they written 20 years ago but really don't accommodate the current industry consensus standards or current government regulations? And looking at that. But then that comes back to now establishing that process for machine guarding. Who's doing it, doing the review as a result. Next one is the training. And you can see by the list on this slide here, it's not just training of engineers. It's everybody that has to do anything with that piece of equipment. So if you look at EHS people, one of the common problems that we see out there is because somebody has EHS or HSE in their title, the people that they work with think that they're experts on everything. It's too difficult to be an expert on everything, and machine guarding is no different. So EHS people need that education, and they may have it on the machine safety side, but part of it, when you see what to train on, is not just the need for safety, but how to operate the equipment. You can't have the defensive walls built up where you have environmental health and safety people on one side and operations on another, and they're sitting there banging their heads or banging their fists saying, you must guard it. I can't guard it because I can't produce the product. That doesn't work either. Break down those communications. So part of that education is educating on the process, how you currently run the equipment, so you can come up with, okay, now that I understand that, how do we guard it? But then that comes back down to training operators. There's a need for safety. We understand it was never guarded effectively to begin with. We're not trying to make your lives more difficult, but this is the reason for it. We want you going home at the end of the day with your families. We don't want you getting sent to a hospital or worse. So ultimately, how do we do that? Why does management need to be trained? Management drives this. Management may control the funding for it, because funding can be a challenge as well, getting that funds. How do you pay for the machine guarding? So when you look at the operation, the need for safety, but then it comes back to how to approach and to identify. Next one, we talked about risk assessment, but I want to go into more detail with this. I've seen some very good risk assessments out there. I've seen some very bad risk assessments out there that don't give a whole lot of information. You want to evaluate your risk assessment process and look at different things. One would be identify your hazards naturally. Everybody looks at that. But don't just look at the visible. Look at what you can't see. Look on the ground, lay on the ground. Can you reach your hand, arm, or leg up underneath the machine and get into hazard point? You may not be able to physically see them until you lay on the ground and see a chain and sprocket is completely open on the bottom. Somebody drops something on the floor and they reach up. Next thing you know, they just lost fingers in the machine because it wasn't effectively guarded. Don't stop at the visible. Look at the things that you can't see. That also includes evaluating controls. You can start putting some great guarding on a machine that effectively protects people, but if you don't have the right switches and they're not wired in properly, or the e-stop is wired into a standard PLC input and it doesn't remove the hazards of the machine, you can have simple failures that can occur and still lead to an unsafe condition. Evaluate those controls to understand what you have and if anything is needed. Maybe you have a proper Category 3 control reliable circuit that's required per the risk assessment. But until you evaluate that, you don't know. You quantify it, meaning you put a number to it. What does that really do for you? It's going to do two things. It's going to help you prioritize what you need to do, and then it's also going to help you decide what is the acceptable level of risk. But anything that you identify, you want to establish a control measure or a fix to. And what we mean by that is, here's the hazard, these are the issues, this is how we want to see it fixed. We want to put a light curtain over, a hard guard with an interlocked door here, and tie it into a Category 4 circuit. That's what we need. That's the control measure of the fix. The implementation plan, we talked about this. It's developing what you need to do, how you're going to go about doing it in the design, but establishing a realistic timeline. Not just a timeline, what's realistic? Knowing that you have all these hazards to take care of, saying we're going to have this done by the end of the month is not realistic. Maybe it's a 1 year, 2 year, 3 year process, and you're going to start working with the highest priorities and work your way down as a result. The last one being the integration. And to me, one of the most important points here on this slide is make sure you balance safety and productivity. You cannot sacrifice one for the other. You cannot say it can't be guarded. It needs to be guarded. The question is, how do you guard it? But if that guarding completely stops you from producing, that doesn't work either. You have basically just a big piece of metal that does nothing at that point in time for you. Where's that balance? Where are your resources? Who's doing it, internal or external? Make sure you review the designs before guarding is just thrown up. You understand where access points are. You validate it. You prove it out that it works. And that all then comes down to the hierarchy. This was taken from ANSI B11.0, but there's a lot of different charts and methods you see in different standards that are doing a lot of the same type of scenario. It's a hierarchy. You first try to eliminate it, then you engineer a solution, and then you add administrative controls with awareness, warning signs, making sure people are trained on safe operation and the PPE. What's most preferred versus least is because what's most effective. If we can eliminate the hazard, it's gone. If we can't eliminate it, how do we effectively protect people from serious harm? That's what this chart is trying to get to. So now, this was the original list of the reasons for the challenges of machine guarding, and we went through each one of those, but in continuing with that, if we look at justification of not knowing, we can't accept it as a practice. It comes back to education, learn it, and put that safe culture into place. These are just, not that they're all-encompassing, but these are just some of the points that can be done to help you overcome those challenges by implementing some of these concepts and ideas. Not designed for safety, an existing piece of equipment. Make sure you review how it needs to operate. Look at and review designs of guarding. How can we effectively guard it, as well as being productive? It might be a combination of different concepts and thoughts and ideas to come up and develop and implement a great solution that is productive. It may require a machine redesign. Okay, just because we know what the function is of the machine, maybe we have to redesign the machine and make changes before we can implement the guarding to make sure we can do what we need to do to effectively guard it and still be productive. The resources. Help prioritize if you're using internal resources, meaning you may have engineers working on specific projects, but is that project a higher priority than machine guarding? Can machine guarding move up higher on the priority list? If it can't, that's understandable as well because you have a limited number of resources. Investigate external resources. Are they competent in machine safety the way you need them to be? Funding, as I mentioned, is a big issue. Do you get the funding? What's the cost of safety? Well, ultimately it comes down to what's the cost of an injury. You may spend thousands, hundreds of thousands, or even millions on machine safety, but if somebody gets seriously hurt on the machine, how much does that cost the company because that money wasn't spent in there? And you can't just magically make money appear overnight. Part of the process is it takes time because you may have limited funding, but your risk assessment helps you prioritize that and move on down the list. The education factor, how do you expand that? There could be online tools, webinars just like what you're attending today can help you break down that process a little bit more. Full day training sessions specific to machine safety. There's different resources out there to be able to do that, but understanding how your machine works is going to help you develop a good guarding solution. Understanding of the standards comes back to knowing what standards are applicable, finding that out, and work on your interpretation of that. But that also may come down to utilizing your external resources to help you with that. The process, if you're missing it completely, get a process in place. That's going to show some progress and make things better for you in your workplace. Find out what you're missing. What do you have to fill the gaps in with as a result? Put that into place, but be strategic. You can get so blocked in by constantly trying to rehash and make the process perfect that it takes you a year or 2 years to put an effective process in place. Well, you just lost a year or 2 years of machine guarding, and people may be getting hurt as a result. Don't let trying to perfection stop you from putting something in place. It's going to be a living process, a living document. I'll work with it and improve it as you go along. Get the risk assessment done. This is fairly straightforward. Understand where your hazards are, what you need to do, define your acceptable level of risk, and prioritize it. And then the last point being the culture at that point in time. It can be difficult to change, as we talked about, but as I mentioned, it does take a good amount of time to do that as a result. You have to have management buy-in. If management doesn't buy in, it's hard to change that culture. It has to be enforced. You have to have the repercussions. It's going to make it very difficult to have an effective machine guarding program and effective machine guarding on the equipment if management isn't driving this with you as a result. Now, ultimately, I think what we can do is put this into 3 simple buckets right now. Education, assess your risk, develop and implement a solution. You can break these down into further bullet points and values, but you can just simply put this in these 3 steps. I mentioned education is so important. Getting that machine guarding knowledge, getting what to do and how to work with a machine and what's going to be effective, that's what's going to really build on everything else. That's your foundation. Getting the knowledge. Knowledge is power. That's what's going to make you strong on putting an effective machine guarding program in place, which then leads into, before you start throwing a whole bunch of designs and putting things in like I call Band-Aid guards, you assess the risk. You perform a risk analysis, do the full assessment, and understand what hazards are, what needs to be done to fix those hazards, where are your priorities, which then gets you into that last step of developing and implementing a solution. Who's doing the design? How's it being done? Internal, external resources. Where's the fabrication being done? What guarding do you need? And you implement it. What do you need to do to implement it and make it effective? I love this quote. I'm sure a lot of you have already heard this from Archimedes. Give me a lever long enough and a fulcrum in which to place it, and I shall move the world. In the beginning of this presentation, we talked about the world being on your shoulders, and specifically with machine safety and the challenges in it. How do we move that? Here's the concept. Education being that strong foundation. There's your fulcrum right there. Going through your risk assessment gives you your lever, but then implementing a solution, looking at your resources to be able to move that lever, address those hazards, get those risks taken care of, you can now move your safeguarding world and provide a much safer workplace for employees, colleagues, companies as a result. So at this point, what we like to do, I think timing-wise, we're at the Q&A session, Bob, I believe.
That's correct, Mike. Thanks. We've got a lot of questions out there. We're going to get to those in just a second. If you'd still like to submit a question, type your question into the question window on the side of your screen and hit the submit button. And while we're answering those questions, please complete the feedback form, which is located at the bottom of your screen. We've got a lot of questions. Safety is such a fundamental right, first of all, for workers, but also something that goes right to the bottom line. It's very often not considered a profit center, but I've always seen safety as a profit center, and these kind of presentations are really important to continue to talk about these issues. Cassandra Bright from RevCore, our first question, can you describe the difference between a Category 3 safety switch and standard switches?
Yeah, there's a lot that makes it different. There is, when you talk, whether it be Category 3 or Category 4 versus a standard switch, it depends on the type of switch you're talking about. So if we talk, say, just a straight limit switch, there's non-safety rated limit switches and there's safety rated limit switches. It comes down to how they're mounted and the construction of the switch. So a standard limit switch, where if you think about a switch being mounted to a machine and you close the door and put pressure against a pin on the switch, for example, that's a non-safety rated limit switch. It's what's referred to as negative mode operation, negative mode mounting. And that's because you can easily bypass the switch and put a piece of tape or a wire tie over it. But also, if that switch were to fail and stick shut or the contacts were to weld, the spring internally doesn't have enough force to overcome it and create an open circuit, thus an unsafe condition. Where a positive mode, positive break type of switch, the spring works in opposite. The spring is used to make the contact. So if the contact were to weld, the sheer force of opening up the door because of camming forces that contact to open. Now you can go also to the more modern technology and see that with electronic technology and the cross-checking of the microprocessors, that they give you those redundant outputs. But when we talk specifically addressing, because the question was Category 3, part of what we need for Category 3 in most interpretation circles is redundancy and monitoring. That's that control reliability factor. So having redundant contacts or redundant switches to get the redundancies because a single point of failure, that we still stop the machine and prevent the machine from restarting until we correct the failure. Now, one thing I always like to note is with talking control categories, which ultimately leads into things like performance levels when we look at ISO 13849, but the baseline with the control categories, it's the device itself can be rated up to a specific category, but what you actually achieve for your safety function is a combination of the devices that are selected and how they're wired up. Just because it may be rated as a Category 3 or 4 switch, if you only wire it up at single channel to a controller, or maybe you just wire it up to a standard ice cube relay or contactor, you are nowhere close to Category 3 at that point in time. It's the combination of the devices you select and how they're wired up to achieve that control architecture. I know that's very generic, so I hope I answered that question how you need it, but just let us know if we need some more details. But we have some past webinar recordings on our website that addresses different control architectures as well as validation and other things that may help with that question also.
Very good. Keith Metz from the New Jersey Department of Labor says that OSHA standards do not cover the manufacturer of the machine to be in compliance, correct? It falls to the user.
When you look specifically at OSHA, OSHA is regulating the user. How do they regulate the OEMs? They regulate them based off of their workplace and protecting their people. But in OSHA's principles and government regulations is they're looking at the workplace and making sure people. So when you look at the general duty clause, it's the employer's responsibility to make sure they're protecting their people from hazards that are known, or I should say known or recognized hazards that can cause or likely to cause serious harm or fatality. The second part of that, an employee has a responsibility to make sure they're working safe as well, but they don't go after an OEM. That's OSHA. However, that doesn't eliminate the lawyers. If somebody gets hurt on a piece of a machine if an OEM or a machine builder tries to claim, well, I'm not regulated by OSHA, well, it may not be very hard to prove that they know better principles and practices to effectively build and design a machine for safety. And because somebody got hurt on their machine, as much as they want to claim that it was the end user's responsibility to put additional safety on there and protect their people, it very well can be found that the OEM becomes responsible and liable as well. And I have heard of several cases like that an OEM tried to stand on the fact, well, there's no existing standard out there, or it was the end user's responsibility, and they lost that lawsuit because somebody got seriously hurt and they knew of better principles and practices. So OSHA doesn't go after the machine builder if there was an issue. It's the lawyers that come after them as a result.
Gotcha. This is a good question from James Quigley at Northrop Grumman. How am I supposed to know if a machine has the correct guards? And this kind of goes back to what you were just talking about with the responsibility for the worker, for the employer, for the machine builder, all the way down the line.
Absolutely. And part of that is I'm going to say that question again. How am I being, he was talking specifically of himself.
If I'm a worker, how
am I supposed to? And it comes from the different perspectives, right? If you could be an operator on a piece of equipment, but it comes back to the knowledge, knowing what machine guarding is supposed to be required. What do you need to look at? If you look at it from an EHS perspective, it's no different, understanding how the machine operates and how the worker is working with it to put effective machine guarding on there. It could be specific standards, and it goes back to when you look at those challenges to see, well, what do we need to do? How do we need to go about doing it? It's a big world out there on trying to figure that part of the process out, and you need to start somewhere, and starting with your process and procedures and the education is really going to be the key to it. And some of the most common things that you can do and look at as a result is, it's one thing, if you can walk up to a machine and knowingly be able to stick your hand in the machine, whether there's guarding or not, if I can easily stick my hand in there and I can get seriously hurt, get bones broken, get fingers crushed or amputated, or get killed on the machine, it raises the question right away. Without having that background and that knowledge, it raises the question right away is this machine effectively protected? Because if I can get seriously hurt by simply doing this, where's my protection at? And making a claim that, okay, there's a yellow line on the floor, there's yellow paint where the machine is, and trying to put in a procedure that says, if you cross this yellow line, it falls under lockout tagout. So nobody should be crossing that yellow line, and that's our form of machine guarding. That's not acceptable. Even within OSHA, when you look specifically in the U.S., there's two different OSHA standards. There's OSHA 1910.212 for machine guarding, OSHA 1910.147 for the control of hazardous energy. Lockout tagout is not a replacement for machine guarding, and machine guarding is not a replacement for lockout tagout. We did a webinar, I want to say like a year or so back, on lockout tagout versus machine guarding. They don't replace one another. They work in conjunction with one another. It's understanding the task. So if you're replacing a cylinder, yes, that's under lockout tagout. But if I'm reaching in to load materials into a hopper, if there's hazardous motion that's in there, that hopper should be guarded. And when you open up that hopper door, it shuts down the hopper so you can do what you need to do, close it, hit start, reset, go back on your normal process and be productive without sacrificing safety as a result. Ultimately, And I know we're getting into a long answer on this one because it's definitely a challenge. It's certainly a challenge when we talk this particular subject, the challenge of machine guarding. It does come back to trying to get that knowledge and then doing your risk assessment to understand how the machine works and what hazards are present to really get to a point, do we have effective machine guarding? Maybe you have great machine guarding already on there, but without the education and doing the risk assessment, how do you say it's okay? Well, if you understand the hazards and you understand that the guarding that's in place, well, this is acceptable. It does effectively protect their people. You have your documentation to back it up, but then you also get that comfort level of knowing that that was done and it was evaluated and adjusted. It might be that you have guarding on there, but with doing the risk assessment, you see complete effective guarding. You got the guard door interlock with a proper safety switch. You got the proper safety circuit. In leading into the preceding question with the Category 3, you got a Category 3 architecture. That's all great per the risk assessment. But next thing you know, somebody drops their pen on the floor and it rolls underneath the machine. Well, they're not locking out the machine to reach under the floor to get their pen. But if you do a risk assessment and you look up, and I mentioned earlier that chain and sprocket, for example, I wish I was making that up. I know of a situation that happened, that what had happened, they laid down on the floor, they reached up to get whatever they dropped or cleaning up parts that fell down there, and as they were sweeping their arm through it, they brought their hand and arm up, but because they were stainless steel panels, they didn't realize that the chain and sprocket was right behind those panels because the machine was still operating, and their fingers got caught in the chain and sprocket and lost the tips of two of the operator's fingers as a result. Even though the guarding on the surface all looked like it was great, it was the risk assessment. In that particular case, it was the injury that drove the risk assessment. You want it the other way around. You don't want the injury to drive your risk assessments because it's already too late. Somebody's gotten hurt. You want the risk assessments to drive the guarding to prevent that injury from occurring.
And that's a great point to kind of wrap up our discussion on is when we're talking about these things, if you can depower a device, take it down to zero energy, and do whatever work you need to do, that's always the first choice. But if you're going to operate a machine that is continuing to run, you first have to do the risk assessment and then have the proper guarding in place so that you can make sure, as you pointed out, Mike, you've mitigated all of the risks that you can and your workers can operate in a safe setting even while the machine is operating.
Absolutely, and that also leads into understand the tasks associated with the machine, because part of what you look at is if, let's say you're being proactive, and that's what we always want. We want to see proactive because none of us, and I hope I'm speaking for everybody on the line, want to see anybody get seriously hurt on the machine. And whether you're being proactive or somebody has gotten hurt on the machine, OSHA comes in for an inspection and they see a task being done. Well, they may question, well, why is that machine not locked out? Well, that's a normal, routine, repetitive task. Well, why is that normal, routine, and repetitive? Because that's what's written in. If it's a normal, routine, repetitive, or considered minor servicing, it falls under machine guarding. If it's not normal, routine, it definitely falls under lockout, tagout. And you can find just on OSHA.gov a lot of different interpretation letters, but every machine is different. Every operation is different. It's really up to the end user to determine what is normal routine, what is critical, what is minor servicing, and to do that, you need to understand the task with the machine and document that. So you can justify to an OSHA inspector, well, this task is lockout, tagout. With what they were doing, because we have proper guarding in place, we've done our risk assessment, and we did what you just said, Bob, was mitigate the risk by putting the safety circuitry in there. You have your justification and documentation, so that's great from a proactive standpoint. If somebody already got hurt, then you're starting to question, did we have effective machine guarding to begin with? Did we have a risk assessment? We didn't do that, but we said you didn't need to lock it out. You didn't have your documentation to back you up. but that backfills in with everything else that you have to do along the lines, and that your training, your process and procedures, it's part of the hierarchy. It doesn't mean you stop doing that. You just start by eliminate, engineer a solution, and then back it up with your process and procedures.
And that's a great place to end it for today. We had a lot of questions from a lot of you, and we didn't get to them during this live presentation, but we will be in touch with those answers after this event. So on behalf of Machine Design, New Equipment Digest, and EHS Today, I first want to thank Mike Drozier for a great presentation, and I want to thank Schmersal for sponsoring today's event, and to thanks all of you from attending all over the world. So have a great rest of your day and stay safe out there.
Definitely stay safe. Wish you lots of luck and good luck on your machine guarding endeavors. Thank you very much.